Hello, everyone. In this lesson, we will learn about the classification and basic parameters of industrial robots. In today's rapidly developing technological landscape, industrial robots have become an indispensable part of the manufacturing industry. With their unique presence, they have greatly transformed our production methods. In this lesson, we will explore the different types of industrial robots, their internal structure, and the basic parameters that shape their performance. Starting from basic knowledge and gradually delving deeper to better understand the working principles and application range of these advanced machines. And also to select the appropriate industrial robots according to application needs. First, let's look at the classification of industrial robots. Manufacturers design specific industrial robots for different application scenarios. There is no unified standard for the classification of industrial robots internationally. They can be classified based on load weight, control methods, degrees of freedom, structure, application fields, etc. Let's understand some common classification methods below. 1. Classification by technological grade of industrial robots. 1. Teaching playback robots, also known as the first generation of industrial robots, can perform tasks repeatedly according to the pre-taught trajectory, behavior, sequence, and speed set by humans. Teaching can be done hand-in-hand by operators or through a teaching pendant. The industrial robots commonly used today are mostly of this type. 2. Perception robots, known as the second generation of industrial robots, are equipped with environmental perception devices and can adapt to changes in the environment to a certain extent. Currently, the most widely used are industrial robots equipped with visual systems. These robots are gradually entering the application stage. 3. Intelligent robots, the third generation of industrial robots, have the ability to detect problems and autonomously solve them. They are still in the experimental research and trial phase. These robots integrate advanced technologies such as artificial intelligence and big data, enabling human-robot collaboration, and represent the future direction of industrial robots. 2. Classification by application of industrial robots. According to the tasks, industrial robots can be divided into handling, gluing, palletizing, welding, painting, assembly robots, etc., which were explained and demonstrated in the previous lesson. You can review it again. Next, let's look at the structure and composition of industrial robots. A typical industrial robot system mainly consists of a manipulator, drive system, control cabinet and control system, teaching pendant, and replaceable end effector. Let's understand the functions of these components one by one below. 1. Manipulator. Also known as the robot's body, it is the mechanical main body of the industrial robot and is used to perform various operations. The commonly adopted jointed structure in robots mimics the human waist, shoulder, and wrist. Modern mainstream industrial robots consist of 6 movable joints, also known as 6 degrees of freedom. 2. Drive system. The drive system is the core mechanism of industrial robots. Each joint axis of mainstream industrial robots is driven by a drive system composed of servo motors and reducers. The drive system is responsible for the rapid movement and precise positioning of industrial robots. The servo motor consists of a stator, rotor, and pulse encoder, while the reducer mainly includes RV reducers and harmonic reducers. 3. Control system and control cabinet. The control system of industrial robots is the brain of the robot. It manipulates the robot through various control circuits and control software, coordinating the robot with other equipment in the production system. The control system of industrial robots is integrated into the robot's control cabinet, which contains the robot's CPU, motherboard, memory, control interfaces, and various cards, as well as the drive circuits of the servo system and the robot's brake circuits. Therefore, the control core of the entire industrial robot system is integrated into the control cabinet. 4. End effector. The end effector of an industrial robot is the mechanism connected to the manipulator's wrist, directly used for operations. It could be a hand, claw, for gripping and handling, a spray gun for painting, or a measuring tool for inspection, further enhancing the flexibility of the robot's operations. Lastly, let's learn about the main technical parameters of industrial robots. When selecting robots, several important parameters need to be considered, including the number of axes, range of motion, load capacity of the wrist, and repeatability accuracy. Specific details can be found in the product manuals of industrial robots. For example, the following image shows the body parameters of the Fanuc M10IA-12 series industrial robots. 1. First, let's discuss the parameter number of axes. The number of axes also represents the degrees of freedom of industrial robots. Modern mainstream industrial robots are 6-axis robots, but some specialized robots have fewer than 6 axes. The more axes a robot has, the more flexible it is, and the greater the control angle and range. Users can select the appropriate robot based on their needs. 2. Working radius. It represents the maximum distance an industrial robot can work. Therefore, when designing a system, this parameter should be fully considered to design the industrial robot's working point without exceeding the range. 3. Range of motion, maximum speed. This parameter represents the maximum rotational angle speed of each axis of an industrial robot. The larger this parameter, the faster the robot's movement and the greater the range of motion. Industrial robots typically work with the linkage of multiple axes. However, the faster the speed of each axis and the larger the range of motion, the faster the speed and the greater the range of motion of the linkage. 4. Load capacity of the wrist. This parameter represents the maximum weight that the end of the industrial robot can bear. When designing a robot, the weight of the tool mounted at the end and the weight of the robot's module tool grip load must be considered. The total weight must not exceed this parameter. 5. Repeatability accuracy. Repeatability accuracy can be described as the robot's ability to reach the same position each time it performs a routine task. The smaller this parameter, the higher the motion accuracy of the industrial robot. Through this lesson, we learned about the classification of industrial robots, became familiar with the components and functions of an industrial robot system, including the manipulator, drive system, control system, and end effector, and recognized the main technical parameters of several types of industrial robots. I believe you have a more comprehensive understanding of industrial robots now. Please review after class to lay a solid foundation for future applications in the manufacturing industry. This concludes today's lesson. Thank you, everyone.